Dear Professor, welcome to this video. In this video, I'm going to show you an innovative agricultural monitoring system that integrates the Internet of Things and cloud services to improve farmers' decision making. I will introduce the background of the project, system design, implementation process, and core function display in detail. First of all, in terms of the clarity of problem description, the real problem we face is the inefficiency of agricultural environmental monitoring. The traditional method relies on manual data collection, which is not only time-consuming, but also has low accuracy. Through the introduction of IoT devices and cloud computing services, the project collects and analyzes environmental data in real time to provide timely decision support to farmers. Next, let's look at the design and implementation of the system. The system architecture is divided into 4 layers. The first layer is the perception layer, composed of SenseHead emulator sensor connected to the Raspberry Pi. It will get the temperature, humidity, and pressure data, and is responsible for data acquisition. The second layer is the network layer. The collected data is transmitted to the AWS IoT core through the MQTT protocol to ensure the real-time transmission of data. The third layer is the data processing layer. In the AWS cloud, the Lambda function is used to receive the transmitted data and store it in AWS S3. And then the Lambda function is used to process API requests and obtain the data in S3. The fourth layer is the application layer. Through the API gateway, front-end web application can obtain the latest data in real time and display it on the user interface. Then on system workflow. First, the sensor collects environmental data and processes it through the Raspberry Pi. Then, the Raspberry Pi transfers data to AWS IoT core via the MQTT protocol. After that, AWS IoT core pushes the data to AWS Lambda function for processing, and the processed data is stored in AWS S3. Finally, users can access the API gateway through a web browser to get the latest data and view environmental parameters such as temperature, humidity, and pressure. Now let's show the core function of the system. The first is real-time data acquisition and transmission. On the Raspberry Pi, sensors collect temperature, humidity, and pressure data in real time and transfer the data to AWS IoT core via the MQTT protocol. And let's check whether the device shadow can get the data properly. Well, it gets the data properly. And next, data processing and storage. The AWS Lambda function receives data for processing and stores the processed data to AWS S3. Let's check whether the S3 bucket gets the data. Well, it's a little bit slow. Let's see the latest data. Well, that's it. Let's check it. Download it. Well, the bucket has stored the data properly. Finally, we perform data display. Users can access the API gateway through a web browser to obtain the latest environmental data. The interface will provide alarms according to different environmental conditions. When the values exceed the threshold, the value will turn red and a warning will be displayed. Well, let's check the latest data. Well, we can see that the temperature is above the normal value, so it's displayed in red color and a warning has displayed. Well, all functions are working properly. In the future, I plan to expand the system to monitor other environmental parameters, such as soil moisture and pH, while using historical and real-time data to predict future environmental conditions and trends. In addition, I plan to use more visual tools to optimize the web interface. This is the end of my presentation. Thank you for watching.